Alright, so this is your lesson on differential equations. So we're going to start with finding the general solution of big F prime of x equals 1 over x squared. So we know that whenever we see that prime symbol, that is taking the derivative of it. So we want to find the particular solution, okay, and the particular solution is of f, okay, just big F, that satisfies that initial condition. So if we know that this is the derivative of f, and we want to know just the original f, then to undo that operation, much like we talked about in Algebra 1, where we would undo addition with subtraction or using that inverse operation, we're going to use that inverse operation, and so our inverse of taking the derivative is taking the integral. So if we take the integral, we know we have f prime of x is equal to 1 over x squared. Then taking the integral would give us just f. Okay, and then we would want to take the integral on the other side, and so that would be taking the integral of x to the negative 2. And we know that we're taking it with respect to x. Okay, so we would say, okay, if our derivative is here, we take the integral, and we have to do that to both sides. So we take the integral of both sides. The integral of a derivative would be the original big F function, and then we're taking the integral of x to the negative 2. So then f of x is equal to, we use our power rule, so we bump this up 1 and then divide by that number. So that would be x to the negative 1, and then divide by that same number, and then plus our constant. So then we know that f of x is equal to negative 1 over x plus c. Okay, and so that is our general solution. Okay, so that was this answer. So that's our general solution. So now to find our particular solution, they gave us more information. So our particular solution is going to be satisfied when f of 1 is 0. So then we just plug that in. So we have, okay, f of 1 is 0. Okay, and so f of 1 would be negative 1 over 1 plus c. And so if that is 0, then we're just solving for c. So that would be negative 1 plus c equals 0. So then we know that c must equal 1. So now that we were given this coordinate here, we had 1, 0, then we could plug it in and figure out, oh, okay, our c is actually 1. So our particular solution is that f of x is negative 1 over x, and we know that our c is 1. So it would be plus 1. Okay, so we have our general solution where it's any constant, and then our particular solution where we were given a coordinate from big F so that we could plug that in and figure out, okay, so our particular solution is where c is 1. All right, in our second one, okay, it says, at any point xy on a particular curve, the tangent line has a slope equal to 4x minus 5. If the curve contains 3, 7, find its equation. Okay, so this its is telling us that we're supposed to be finding the actual curve. Okay, so that would be, finding y. So we want to find its equation. So what is y's equation? If we know that the slope is equal to 4x minus 5. So if we know that the slope is 4x minus 5, we know that slope of your tangent was our derivative, right? So we know that dy dx is 4x minus 5. Okay, so we know by definition that our slope of our tangent line is dy dx. So then if dy dx is 4x minus 5, we're trying to find y. So if I want this dy dx, which is a derivative, to be y, then I'm going to need to integrate. So I can separate these two, right? We have a dy and a dx, so I could multiply this dx on both sides. We've done that previously. So dy is 4x minus 5 dx. Okay, and then I don't want dy, I want y, so I would integrate both sides. So if I integrate, okay, I would then know, okay, so this constant, there's a constant here. It's not written, but I know that there is a constant. If you're just blank and then dy, your constant is 1. So then we know to integrate a constant, it would be 1 times this variable that we're integrating, and here we're integrating with y, so that'd be y plus a constant. And then equals, now this would be 4x, bump that up 1, so it was 1, so now it's 2, divided by 2, minus 5, and that now has an x. Okay, and then this also gets a constant. Now these constants are different, right? They don't have to be different. They could be the same, but they don't need to be. So we would call this C1 and C2 so that we're being careful about saying those aren't the same constant. It's just there's a constant and here's a constant. Okay, so then to get our solution, we would need to get y by itself, so subtract C1 on both sides. So if you subtract C1 on both sides, then C2 minus C1, a random constant minus another random constant, would just be a random constant. So you could just say C, or if you would like C3, just another one. So that is our general solution. Okay. And this 2, of course, came because those two, 4 and 2 canceled to be 2. So then, okay, I'm not sure why my camera's not focusing. So that's our general solution. So then we are given the 0.37 in order to find the particular solution. So we're going to use that 0.37 in order to find that. So we know that in 37, this is our x and that's our y, so we just plug that in there. So we have 7 equals 2 times x squared, so that would be 2 times 3 squared minus 5 times 3, and then plus c, which we don't know. So then we have 7 equals 2 times 9, and then minus 15 plus c. So then solving, we know that c is 4. Okay, so then if c is 4, we know that our final particular solution is y equals 2x squared minus 5x, and now we know our c is 4. So that would be our particular solution. All right, so then, okay, we introduce some more vocab. So an equation that's containing a function and derivatives, or just derivatives, is called a differential equation. Okay, so differential is the type of equation that you have. And so, of course, that is because of differentiation, that you have derivatives. That's where that word is coming from. So some examples are like dy dx is 2x. So you have a derivative and you have a function. So if you have that combo going on, you're a differential equation. Same with this one. This is just the second derivative and 4x plus 3. So you have derivatives and you have a function, so you're a differential equation. A more complex differential equation is one like this. This is more complex, of course, because you have on this side, your function is including an x and a y. So you're more complex over here. You still have the derivative, and then you have this 2x squared over 3y cubed. So when you have this, you're going to have to separate so that your y's go with your y's and your x's go with your x's. So in this example, you would cross multiply. So if you cross multiply like that, you get 3y cubed dy is equal to, and then cross multiply those, 2x squared dx. And so if you're able to do that, if you have some mess like this, and you're able to separate those variables where the y's can be with y's and the x's can be with x's, that is called a separable differential equation. Okay? And so if you go on in math, you will take an entire course that is called differential equations. So DiffEQs will be a course that you take. All right, that's better. It's more focused now. So those are separable differential equations. So now we're going to try a few of those. So example 3, you're finding the complete solution of the differential equations. Okay, so a complete solution is including every constant that you could have, so you'll leave C there. Okay, so in A, we just need to separate, okay, this is that same equation that we talked about, so you just need to separate your y's with your y's, your x's with your x's, so you cross multiply. So we get 3y cubed dy equals 2x squared dx. Okay, and then the idea is to get your solution for y, so we're going to need to integrate. So if we integrate or take the antiderivative, okay, that will be 3y, you bump that up one, so that's y to the fourth over 4, plus some constant. Okay, this one, you have the 2, you bump this up one, so it's x cubed, and then you divide by that 3. And then plus another constant, so just call it C1, C2, so that it's clear that you don't think it's the same number. Okay, and now you're just trying to get y by itself, so subtract a C1 on both sides. So C2 minus C1, a random constant minus a random constant is going to be a random constant. So you just call it C3. Okay, now let's get rid of this 3/4, so multiply by 4/3 on both sides. Okay, and then this will be 4/3 times C3, so 4/3 times a random constant is going to be another random constant, so let's just call that C4. Okay, and now to get y by itself, we're going to have to take the fourth root. So if you take the fourth root, okay, you're going to take that on all sides, so you have 8/9 x cubed plus c fourth. We'll just deal with the positive side. So then this can be your answer, or you could separate it out where the fourth root of c to the fourth, or c4, would just be another random constant. So if you want to separate that out, you could. Okay. So then if you would like to, you could also write the fourth root of 8/9 x cubed, and then plus c. Okay. All right, so for B, in B, and here we just dealt with just the positive side. Okay, so B, you have the second derivative, so again, you just kind of go slowly. So if you want to get y by itself, first we're going to need to integrate here. So already we know, okay, we're going to integrate. If we integrate the second derivative, you would get the first derivative, right? So if you integrate the second derivative, you would get the first derivative, so that would be dy dx. Okay, and if you integrate this, you would get 4 x to the, you would bump this up, he's 1 right now, so it would be x squared over 2, and then plus 3x. Okay, so of course you're integrating with respect to dx. Okay, so if you integrate the second derivative, you're going to get the first derivative, and then you integrate on this side, and you have a constant. Okay, and then now we have dy dx, so we're going to need to do that again. So we have dy dx, but we want just y, so let's separate those. You can multiply by the dx on both sides, so this would be 2x squared plus 3x, let's call this c1, times dx. And then again, we're not there yet, we want y, so we're going to need to integrate again. So if we integrate here, the integration of dy is just going to be y plus a constant. And this is going to be 2x, you bump it up one, so you get 3, so you get another 3 at the bottom, plus 3, this x is going to be bumped up to a squared, so divide by 2, and then this is a constant, and a constant is that constant times that variable of integration, so ours is x. Okay, so that's the integration of this one, this term, and c1, and then of course we also have another constant, right? So we have to add in another constant. So this constant, we don't know what that is, but when we integrate it, he got an x, and then we have another constant. Okay? So we can call this one c3 if we want. Or whatever you like to do to kind of keep track of these things. So then your y, we get rid of that c3, so 2/3 x cubed plus 3/2 x squared plus c1x plus, and then c2 minus c3, let's call that c4. Okay, so that's our general solution. And so that time we had to integrate twice because it started with the second derivative. Okay, so for this C, it says find the particular solution of that diff EQ in B. Okay, so they give us all this information. So we're trying to find the particular of this one. Okay, so if we're trying to find the particular solution of that, then we're going to need to use a couple different things. So here we have y, x, c1, and c4 as a variable. So we can't solve for this all at once, so we're going to need to be kind of strategic. So they gave us that y is 2, y prime is -3, and x is 1. So we're going to be plugging those things in. So we know y is 2, so if we start with this one, we would say, okay, y is 2, 2/3, x is 1. Okay, we don't know who C1 is. C1, x is 1, and then we don't know who C4 is. So if we start with this equation, we realize, oh, I can't solve this. I have two variables, so I must have to start somewhere else. So this might be helpful later, but I can't solve this because there's C1 and C4. So then you look up and you try to figure out, okay, where else could I plug these numbers in that would help me? So I have y, y prime, and x. So here I still can't because I still have all these C2s and C3s. So how about here? What if I plugged it in there? I would be able to plug in y prime is the same as dy dx, right? So y prime, I would plug in an x, and then I would just have the C1. So let's start there. So our y prime, they say, is -3. So we'll put that in there. So y prime, remember, is the same as dy dx. So I'd have -3 equals, this became 2x squared, right? And our x is 1, so 2x squared plus 3x plus c1. So that's here. So using what I circled in orange and using this blue equation up here. Okay, so now I have this, I can solve for c1, right? So I get -3 is 2 plus 3 plus c1. Okay, so then solving for C1, I have this as 5, so 5 and a -3. When you subtract the 5, we'll get -8. Okay, so I know that C1 is -8. Okay, so that helps me. So this one would be -8 here, but they're asking you for the particular solution of the differential equation. So you want this one. So you want this to have everything filled in. So we have C1, so now we know C1 is 8, so that's, or -8, that's helpful. Now we just need to find C4. So let's go back to this equation then now. So now I'm almost there, right? I have that this is -8. I still just need to find who is C4. So now I can plug it in like I had before, but now I know who C1 is. So C1 is -8. So now I can plug that in there. So I have 2, it's 2/3 plus 3/2 minus C1 is 8, -8, -8, and then plus C4. Okay, so then I'm going to need a common denominator, so this becomes 4/6, this is 9/6, this would be 48/6, there equals 2. So that's -35/6 equals 2 plus C4. Then I add 35/6 to 2, so that is 47/6. Okay, and of course if you prefer decimals, go for it. So 47/6. All right, so now I can plug everything in, right? So I have a y and an x, that's totally fine. I just need to find C1 and C4, so I got both of those. So I have C1 and I have C4. So then my general solution, or my particular solution, when I plugged all this in, was that y equals 2/3 x cubed plus 3/2 x squared, and the C1, remember, is -8, so -8 x, and then plus C4, and C4 was 47/6. So that is my particular solution. So that was just a bunch of algebra, just getting there. So I got to here using calculus, And then after that, this part C is just algebra. You just have to plug in a whole bunch of stuff to different equations until you can find who is C1 and who is C4. Okay? So then that's how you get your particular. Okay, so then your last example on the back. And this example is also asking for a particular solution. Okay, so with this one, you just have to be careful with separating your variables. So right now, your x's are with your y's and your y's are with your x's. So let's just kind of rewrite, clean this up. So x to the negative 2 means you're 1 over 3x squared, right? That's equivalent. So 1/3 x to the negative 2 is 1 over 3x squared. dy, you have y squared dx. Okay, so I want the y to come over here with the dy, and I want the x to come over here with the dx. So I can move this over here by multiplying by 3x squared on both sides, and I can move this y squared over here by dividing by y squared on both sides. Okay, so I divide y squared on both sides. So dividing by a y squared would get me 1 over y squared, right? Dividing by a y squared. Okay, and then moving this 3x squared over here, I would multiply by 3x squared. Multiply by 3x squared on both sides. And so now my y's are with my y's and my x's are with my x's. Okay, so that's the first step, just being solid in your algebra in that way. So getting rid of a y squared, you would divide by y squared on both sides, which means it's in the denominator. And then getting rid of the 3x squared in the denominator means you're multiplying on both sides, so it's now on the numerator. Okay, so now I know that I'm trying to find the particular solution, so I need to find y. Okay, so right now I have a dy, so I need to integrate. So when I integrate, it's easier for me to look at this as y to the negative 2. And then I integrate 3x squared dx. Okay, and if you want to rewrite that, you can pull out the 3. Okay, so then to integrate this, you bump that up 1, and then you divide by that number. So it's going to be y to the negative 1 over negative 1 plus a constant. That's where you're going to have 3, x to the, bump that up 1, so that becomes cubed over 3, and then plus a constant. Okay, so this becomes y to the negative 1 is y in the denominator, and you're negative, so you're negative 1 over y. All right, and then let's subtract that c1 on both sides. These cancel, right? So you get x cubed. So then c2 minus c1 would just be another random constant. So let's just call that c3. Okay. Now we're trying to get y by itself, so let's multiply by that negative on both sides. Okay, and I'm kind of sick of doing all these c's, so I'm just going to keep that as subtract c3. So if you wanted to, you could make, okay, minus c3 is the same as, oh, c4, but I don't want to make any more c's today. So I'm just making minus c3, so you just leave it like that. Okay, so I want to get y. Okay, so depending on how strong you are in your algebra skills, if you have y in the denominator and you want it in the numerator, you can take reciprocals of both. But if you do not remember that, I don't want you to be like doing random things like that. So the reason why is you're cross multiplying here. So if you cross multiply, you would get y times the quantity negative x cubed minus c cubed, and then equals 1. And if I want y by itself, then I would divide both sides by this whole quantity. Then I would get y equals 1 divided by negative x cubed minus c3. So if you notice, if you're here, you could just go straight to here if you know, okay, this is 1 over y, so then this can become y, and this will be the reciprocal. But if you didn't know that, do not try to memorize that, because I don't want you to do it wrong based on memorization. The reason is you're cross-multiplying, and then you're dividing on both sides this whole quantity. So that's why it gets to the denominator. All right, so this is our general solution. Okay, so we have the C3, but they wanted us to find the particular solution. So we have that y is neg 1 and x is 1. So y is neg 1 and x is 1. So we just plug that in to find what C3 is. So neg1 equals 1 over negative x cubed, so x1 cubed is just 1, minus C3. Okay, and then if you would like to, you can cross multiply, or however you know best how to do this. Okay, so then if you do cross multiply, you would have to distribute that negative 1, so you get 1 plus C3 equals 1. Subtract 1 on both sides, and you find out that C3 is 0. Okay, so then if C3 is 0, now we know, okay, that was our general solution. So now our particular solution is that C3 equals 0. So our particular is that y equals 1 over negative x cubed. Okay, so there would be minus 0, so that's why that's gone. So you can write it like that, or you could write it like this. But that is your particular solution. Okay. All right. So that is your lesson for differential equations. So the big part is just being able to be consistent with your algebra, so that once you do your calculus, once you integrate, you can work to get your constant of integration so that you can find your particular solution at the end.